Hello, class. I'm here to talk about chapter 12 that we are covering this week, linear regression and correlation. And pretty much uh, a linear regression can help you determine if, in this picture example, if an auto mechanic's salary is related to his work experience. So we're going to see if there's a correlation between these two. Chapter 2 is pretty much working with simple linear regression and not with multiple linear regression. A simple linear regression, it works with two variables, in this case, for example, salary and work experience. Multiple linear regression, it tries to identify the relation between two or more variables. Okay, so we're gonna go over the simple linear regression and also talk about correlation coefficient, which is very important in R squares. And I have posted some pictures on your discussion to show a weak correlation, a strong correlation, a negative correlation, a positive correlation, so far, so on. And hopefully, when we go over the problems, we're gonna be understanding this better and better. Um, the chapter starts by saying that a linear regression for two variables is based on a linear equation with one independent variable. So the equation for the linear equation is represented right here in your book. I make it bigger by y, which equals a plus bx. Variable and y is the dependent variable. That means every change in x, which is your independent variable, you will change y because your y is your dependent variable. And again, this also is going to be clear when we start working on the problems. I'm trying to think of an example. If you were working with, okay, let's say that I do tutoring. I offer tutoring, and I say that I charge $25 for tutoring. My fee, my minimum fee is going to be $25. And for every additional hour, I charge $10. Well, in this case, the amount of money I'm going to make, it's going to depend, the amount of money I'm going to make is going to depend on my fixed fee, which is $25 to start, plus $10 times the number of hours that I have spent additional. So this isn't, it doesn't depend on anything. This is just gonna change as in the longer I spend with a student, the longer of hours I spend with a student, then this is gonna increase or decrease, but it's not dependent on this. Why the amount of money I make is dependent on the number of hours. Okay, so I hope that makes a little more sense and with time just makes it easier. So again, keep in mind the linear equation, you're gonna see it as this format. However, you might even see it differently. You probably remember mx right here, m for the slope, correct? Or you can see beta 0 and beta 1 or beta naught. They call it 0 or beta naught instead of seeing the A and the B. You might see different formats. However, the actual linear regression, or they call the line of the best fit, which we can go kind of jump ahead a little bit. Here we go. The line of best fit, you're gonna see just different as y hat. The least square line or line of best fit is gonna be y hat equals a plus bx. Let's just, if you don't remember any of this, where A is your y-intercept, oh, right here, and B, it's your slope of your graph. Okay, let's go back here. I actually want to start with problem 74. And the reason for that is problem 72 is talking about year 2000, 2008, so far so on. And I really want to show you, if you did not have Excel or a calculator to do any of this for you, the amount of calculations you would have to go through just to get your y-intercept, to get your slope, to get your R, which is your correlation coefficient result. So let's just start here where I have X and I have Y. I just labeled in, this is problem 74. However, I labeled in as X and Y here because for the formulas that we're going to be using also is going to make easier for you to understand. So let's suppose that I did not have all the formulas that I'm going to be showing you. What you would have to do to find your y-intercept and to find your slope. So right here I have x, y. Over here I have x times y. The values of x squared, the values of y squared. And actually I'm trying to do this. All borders. What I'm gonna do first, I'm gonna sum. So the sum of x, right? Then I'm gonna also just gonna drag it here. You do not need to do this. I'm just gonna show you that if you did not have the formulas and the data analysis, what all the calculations you would have to do. So right here you have the sum of the y's. Okay. Um, I don't want it like this. I want it bigger. Right here we're gonna do x times y. So I'm doing x times y. And I'm just gonna drag it down so it copies the formula, and right here it's sum everything for me. Right here I'm doing x, this value is square. Again, you don't need to do this, I'm just showing you. Okay, drag it down, that's my total, and here I'm gonna do y square, and then I'm gonna drag it down. So here you have the sum of um, xy, correct? Xy's, correct? Here you have the sum of x squared, correct? And here you have the sum of y squared. And here is the formula. So let's first do your y-intercept. So if you didn't have anything, any of the formulas, you would have to do, I'm following the top. This is what I'm gonna do. I'm gonna do the top part, I'm gonna do the bottom part, and then I'm gonna divide it uh, afterwards and then get my y-intercept. And then I'm gonna do the same thing with my slope. Okay. And another thing, we need the number right here, which will be like you've seen it before, a sample size, but number of variables, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, correct? Count 10. Okay. So let's just, so we don't forget, let's put that n is equals 10. Okay. So don't forget right here, A is equals to, let's start, the sum of the y's, the sum of the y's, so this is my sum of y's, correct? Times the sum of my x squares, sum of my x squares, minus the sum of my x's, the sum of my x's, times the sum of x and y's, the sum of x and y's. Okay, I did the top. Let's do the bottom now. So I have my number of variables, 10, times the sum of x squares, minus the sum of my x's and then square. Okay, this I did this mistake before, so it's the sum of the x's and then square. Okay, now I'm gonna divide the numerator by the denominator. So equals this value divided by this value, and this would be um, my y-intercept. Let me put it 43. Okay, now let's do the slope. So we have the sample size, which is 10. I'm over here, times the sum of x and y's, the sum of x and y's. So it's over here. Oops, I didn't put the equal sign, right? The sum of x and y's, right? I'm talking about the top part of B, of the slope, minus the sum of my x's times the sum of my y's. I'm over here. That's my top part. My bottom part, it's going to be, again, number of variables times the sum of x square, minus the sum of my x and then square. The sum of my x and then square. Okay, now let's divide numerator by the denominator. Is equals to, here we go. That would be my slope, which we can leave it like that. So your linear regression equation would be, you're gonna have y hat. Let's see if this works. It works. Equals to, let's put even separated your, oh no. Okay, let's just put one format. Sorry about that. Equals to your y-intercept, so 102.43 plus 11 your slope times, or x, should I say. So then you would have your line of best fit right there, your linear regression equation, right? Is right as y hat, and is the estimated value of y, which is your prediction. It's going to be these values. Okay, now let's say that I don't, another thing you're going to need is, if you do not have the data analysis on your Excel, you're going to have to install it. I provided a video how to do that, which is basically going file, you go in options, you go in add-ins, and right here you're gonna have an analysis tool pack for Excel. I already have it, so it's not available. It has to be under Excel add-ins, and then once you select, you click in go. If you click in OK, it doesn't work. Click go, it's gonna add, and then you can do OK. See right here now, I have the data analysis. Let's say that you didn't have the data analysis and you want to find the y intercept for this values right here. Okay, so the way we're gonna do, it's gonna be intercept. You just type equals intercept, automatically ask you which ones are the y's. These are my y's, correct? Which ones are my x? These are my x. Close, enter. Here we go. You do not have to do any of this calculation here. None of that. There we go. And then you want to know your slope now, B. So let's type slope. Which one are the y's? Which one are the x's? Enter. And then you find the same value. Here we go. And you also didn't need to do all this. So like I said, you don't need to do all these calculations here. Excel can do it for you. Even if you want to do the R square, I think correlation. Yes, correlation. In this case, array 1 and your correlation array 2, enter. And the correlation that we're going to be learning in this chapter is that a correlation is going to be anything between minus in correlation coefficient is going to be anything minus 1 and 1. Again, a correlation coefficient is going to be anything between minus 1 and 1. A R square is never going to be minus 1 because it's square. Therefore, minus times minus, it's a plus. Okay? So your R square is going to be between 0 and 1. Okay? So here I just did it. What does this number mean? I also put another thing on your discussion that, oh, actually, I had a website. I wish I could find it here that can tell you there was a GIF image. I'm not sure where I put it. That it shows you that the closer it gets to positive 1, it has a positive correlation. They go up together. As one goes higher, the other one goes higher. And then the same way for it, once you see it closer to a minus 1, that means they are on an inverted relationship, therefore it decreases. So you really want something that is closer to 1 to show a positive, strong relationship. Or, depending what you're trying to show, you can hope to have a closer to minus 1 to show there is a negative, strong correlation in your graph. The R square is just to make it that this value right here. So if you put R square, you could just do this time this square, or R times R is the same, but let's just do it the way the formula tells us if you didn't have all that, and enter. Your R square is known as the coefficient of determination. The R square is better used on when we're working with simple linear regression, and it's not so easy to explain the relationship or the correlation in a multiple linear regression by R, so we have the R square. Okay, so now that I have showed you all this, we do have even another way, which is better than all this, that is going to give you all this information and more. But for that, you're going to have the data analysis installed on your computer. Okay, so let's just delete all this that we're not going to need any of it. Let me see if I'm missing anything. No, not really. Okay, I'm even deleting this formula, all this. I don't want you to get confused by it. I put this for you to remember which each variable means, which I have gone through dependent variable y, independent variable x, a is your y-intercept, and b is your slope of the line. You have, I'm sure you remember from other classes when we're talking about slope, how we graph that, the rise over run. I put it here too. I can get rid of that because now I want to show you. First of all, let me show you how to graph this. That's one thing you're really going to need. You don't need the data analysis to graph this information. All you need to do is select your information, select your columns, okay, and then you're going to go in Insert, right here. Insert scatter, X, Y, or bubble chart under chart. See, so again, insert chart right here, the first one. First scatter. See how just by going over some of this, it already gives you an idea. So let's get the first one. And then it lets you format. And honestly, for your homework and for your final exam, we don't need to make it cute. We just need to get the right answers. Okay? So right here, always telling you, it places your y on the y values and it places your x on the x. And right here is saying your values go from 0 to 120. And really, your minimum here is, let me make a better graph. Not cute, like I said, but at least um, your max. So let me do for both. So right here, we have a minimum of 22 and maximum 110. So let's click right here, click the mouse over here, select this horizontal axis, okay? And then click the right button and go in right here, format the axis, and it opens another option. Well, the minimum is 22, so I really want it to be 20. And my max is 110. Not so happy with it. Um, just, yeah, let's just leave it. Okay. Right here, let's do the same thing. I just click this y-axis, click the right button on the mouse, format the axis. My minimum right here is 362. Let's do 300. And my max is 1454. Let's do 1500. Okay. I just want to make it a little better over here. The thing is that is not showing you the zero values, but what I'm really trying to show you here, this values that it plot x and y for me, and it plot uh, every single value. For example, this, if you look for it, 60, this would be right there, 60 and 790, and then it plot for me at 28. So let's look for 28. Here we go, 28. And when x is 28, then y is 428. Okay, so now that we have the graph, without even going much further, do you think that this data, which I don't even haven't even looked at here, says the height of notable tall buildings in America is compared to the number of stories of the building, and is asking if you believe there is a correlation. Yes, definitely. I mean, without even plugging anything, I can see a positive. Do you see the values going from here up? I can see a positive and not so, actually a strong relationship right here. How can you know what would be the line of best fit? Here's very simple. Let's just pay attention. Just click one of this and go right here. Do you see where it says add trend line? Click on add trend line. Here you go. You already is marked for a linear. It's showing me a linear uh, regression. Now scroll down, and what you need from here is display your equation on the chart and display your r square value on the chart. You don't need a y-intercept. So you just need this tool. We can close it here. Here you go. Remember how we have calculated this before? So the thing is, you're gonna see on your book that some places do list, I think it's on your summary of your book, and I might have made this way too big. Here we go. It says that algebraically, a linear equation typically takes the form of y equals slope times x plus b. Statistically, we have turned that around. However, in the equation right here, if you can keep reading all that, but I just want to show you that, uh, like if you're in your doing college algebra, that's the format you'll be seeing your equation. In your case right here, our line of best fit, which is really our prediction line, it's gonna be y hat is equals to, and then you just have to copy from here. You could even copy and paste here, but you're gonna need these values. So 43 plus 11.758x. Okay. You don't need to put your r square here yet. Let me move this. So let's go to actually to the questions and start answering the questions for problem 74, since we already started with all that, right? 74. Here we go. Here we go. So I have put the data, right? And then let's go using stories as the independent, that means X. This is stories. And I'm right here. In height as dependent variable, make a scatter plot. Here we go. I just did that. Okay. B, does it appear from inspection that there is a relationship between the variables? Yes, it definitely appears. We see that it seems to have a strong positive correlation, or actually in this case is asking relationship. Okay, so C, calculate the least square line, which is the line of best fit, and put in the equation in the form which I just did right here. D, find the correlation coefficient. Is it significant? Well, remember, like I said, you could use the formula, but here's how I'm gonna show you how to get all the values for the rest of the problem. And I know this video is turning out to be long, but it's important that you understand this because then it's easier to do the rest. Now that you have installed the data analysis, you're gonna select, you don't need to select. You can just click in data analysis and then it's gonna pop this and you're gonna look for, we have several things for the next chapter, ANOVA, and I believe there is the F test. Here we go. So we're working with regression. Okay, let's click regression. Which ones are my Y's? Then select your Y's. It's okay that you select the label. I'm gonna show you how you can tell Excel that. Now let's select all the X. Okay, so now I have select all the Y's and all the X. It does have labels, so tell Excel it does have labels. Let's keep a confidence interval at default 95%, or it'll be 1 minus the 95 for 5%. Output range. I want it actually just click over here to go back and select the cell. I want it to put the output starting right here. Okay. I want it shows me the residuals. I want it shows me the standardized residuals. I don't need the plots. I don't need graphs for that, and I don't need probabilities. And then all you have to do now, I'm gonna leave it here for a minute so you can see it. If you're following the video, I have select all these cells right here, B's for Y, for the Y range. For the X range, I have select all the A's. And then I told Excel, yes, it does have labels on this data. Keeping my confidence interval level at 95%, always gonna leave it that. I wanted to put all the information that I'm asking over here, starting over here. I could put in another worksheet, another workbook, but I want to keep down here so we can see it. And I don't need plots, I don't need graphs for my residual, for my line fit. I already have it here. And I wanna the information for residuals and in standardized residuals. And we're gonna click OK. Here we go. And then it's gonna provide you all this information over here. I have also provided on your discussion something that looks just like this, and actually it explain each of these variables. For the next chapter, we're going to be using these values right here. This will be actually the p-value for my um, F test, which I'm not going to address right now. Do you see how it's like this? It's because you need to format differently because it didn't. It's a lots of zeros. If you actually keep an eye over here, if I add the decimals, see how it changes? Because there's several zeros before, so you put in this weird format. Okay, it depends how your Excel is formatted. What is important from here? What is your y-intercept? Does this look familiar? So if we didn't do the whole calculation like I did first, if we didn't use the formulas the Excel had for us, then I still had this on the data analysis that gives me all this information. Not only gives me the y-intercept, I can just reduce the number of digits. Here we go. I have my slope x, correct? Let's leave it like this so it matches over here so you can see. What else does look familiar here? Did I tell you about an R square? And did I tell you about R and R square? Sorry about that. Here we go. Remember that I did correlation and then I put the values. Remember that I did that earlier? Okay. Here we go. It's the same thing. What does this mean? Remember, my correlation is between -1 and 1, right? It's considering a formula. So let me see if I can do, perhaps I can -1 and 1. There we go. I just had to put a little space. What is telling me that this is almost 1. It's a very strong relationship. Correlation, I'm sorry. It's almost 1 positive. Another very super important thing, even if it was negative, if the correlation would be negative, Excel is not going to give you that value. It's not going to put that sign for you. You would have to know, it would give you the R value, but how would you know it's a negative? You would go from here down. You go from top down. Would be the other way around. I have put some examples on your discussion. Okay, so right here we have a positive. It's going up. Do you see it? From the origin up, and it's a positive, then in this case almost 1, so it's a strong relationship. What is the R square? The R square is always gonna be positive between 0 and 1, so is also a strong value. You could see perhaps as a percentage value, okay? But I don't want to do that. But it's always going to be positive because it's a value, so it would be pretty much this value times this value again. There we go. Right? Those are the very important information you can get from here. Your standard error as well. But another thing I want you to look here, and the reason I put these residuals is because one of the problems it's gonna ask you about outliers. Well, by looking at this graph, if this is my line of best fit, I want to be so large. If this is my line of best fit, by looking at this graph, would you find any extreme outliers? I would say pretty much this one right here, right? So let me add a label to that. So 1050. So I'll say this value right here would be an extreme outlier. How can I confirm this? When you read the chapter, it's gonna tell you that any values, any scores, two standard deviations or higher, or two standard deviations or lower than the mean would be an extreme outlier. How do we know that? Right here on your standard residuals, this is what we're gonna do. We're gonna type minimum of all these values right here, and then we're gonna type max of all these values right here. Okay. Well, your minimum really um, it stay within two standard deviations. So no, I will leave it alone. But on your max, we have something here over two standard deviations. And which one would that be? That would be the first observation. Your first observation is two standard deviations above of what we predict. Which one is your first observation? This is your first observation. Which one is over here? That's your first. See the points? 57 and 1050. There you go. We answer because even though this looks like an outlier, really it's still within the acceptable, which would be observation number 7, right? 7, right? 1, 2, 3, 4, 5, 6, 7. I don't know why I'm doing that if I could use the Excel to count, but that's okay. So it's saying that this point right here could possibly be an outlier, but is still within my uh, two standard deviations. But this, no, this is really out there. And even this one right here, let's see, 100, that would be my ninth observation right here. See, is still within two standard deviations, therefore not an extreme outlier. So in this case, just this one. So let's go back to the questions. Find the estimated heights for 32 stories and 94 stories. Well, how do we do that? Well, if it's using stories as the independent, which is x, find the estimated heights for 32 and 94. All you have to do is to get this equation right here, and then you're gonna do equals to the intercept plus the slope times, and then right here it says 32. That's your answer right there. 478 point. Uh, this is height. So let me 478.7. Okay, then let me copy this formula down. And now I'm gonna change now. The formula is for 94. So I want to put times 94. So it's 1,207.7 feet. We can even add one if you want. Doesn't really matter. And then you would have answer E, and then F. Based on the data, is there a linear relationship between the number of stories in tall building and the height of buildings? Oh, definitely there is a linear relationship. That's your line right there, proving that. Um, are there any outliers in the data? Is so, which point? Well, I just told you your extreme outlier. This is it. What is the estimated height of a building with 6 stories? Does the least square line give an accurate estimate of height? Okay, if you have 6, so let's just put it up here. Now you only have 6. 173 feet. So does the least square line gives an accurate estimate of the height? Explain why or why not. So 100, and how much is that in 6 stories building? 173. So let me do feet to meters. So 173, 52 meters. Um, No, I would say that no, it does not give an accurate based on the least square lines. Adding an extra story is predicted to add about how many feet to the building. We're saying that if x it's your independent variable, and we are predicting by multiplying by 11.758. So each story that you add um, is gonna add 11.5 uh, 58 11.758 feet. Each story that you add is gonna add 11.758 feet. Okay. Next, what is the slope of the least square line? The best fit. Interpret this slope. So the slope with it's right here. We know is also 11.785, and again 11.7585. So as the number of stories increase by one, the height of the building will also increase by one. That's what this means, which you just pretty much answer on the previous one. And this you're gonna be using for the next chapter. You could even go ahead and delete it from here if you want it. Um, right here, I believe there is a question that talks about rejecting or accepting a null hypothesis. Just keep in mind these are your p-values, and then if they provide you an alpha of 5%, you will still do the same process as is the alpha higher or smaller or lower than the p-value, reject or accept. What else can I think from here? Teach that, you're not going to be asking that. And that's all I can think for problem 74. We actually answered them all. Long video, but I sure hope it helps